For our first keynote, please welcome Neil Mitchell. So Neil is based in Cambridge. He uses Haskell at a tech company, and he's probably known for some projects like Shake, the Shake build system, the Google API for searching Haskell packages, and HLint, a static code analysis and stylistic improvements tool for Haskell. And he's going to give a talk about the Haskell IDE engine, building a Haskell IDE. So please welcome Neil.
Thanks very much. And thanks very much for inviting me to this hackathon. It's really awesome so far. So I used to be a Visual Basic programmer when I was 18 maybe, and then I was a C++, did a bit of Java, and all those languages, at least if you're using the Microsoft tools, have really awesome IDEs. So then you come to Haskell, and obviously the first thing I get is jealous and a bit depressed that I don't have this for Haskell. So in this talk, I'm going to kind of take you through how we can get there, where we are now, and where we've been going in the very recent past to get us to an IDE. But before we start, let's see where we are now. So which editor do people use? So who uses VS Code? I do. Okay, a few. Who uses Emacs? Vim? Oh wow, we have the Vim crowd in the house. Any other editors that I haven't called out? Atom? Gedit. Wow. That's the brave that's the person who really knows Haskell. Okay, and so that's where we type our code. How do we know if our code has errors? So who gets kind of the feedback, the red squigglies from something like Haskell IDE-engine? It's a handful. GHC mod? A handful with questionableness. GHC ID? Okay, reasonable number. Just GHC? Yeah, again, a reasonable number. Just building? Okay, not a huge number. Who else uses other ways of getting feedback on whether their code is correct? Fly check in Emacs? Yep. Yep. Cool. And so once you've got your working code, or when you're writing the code, you want to usually explore. So what type does this have? Where is it defined? How might I use it? What's the docs? So who uses kind of the code exploration techniques in Haskell IDE-engine? One or two, a few more actually. GHC mod? No one really. Hoogle? Yep, I do. grep? Yeah. So in my mind, an IDE is really just somewhere you type the text, somewhere you get errors faster, and somewhere that helps you explore the code, so it makes it easier to write new code. So who wants more from their tools than they've got already? Yeah, pretty much universally. The Haskell tools suck compared to every other language. So the great thing about writing blog posts is you can go back in time and quote yourself. So in 2014, I wrote that with the IDE, I'm about 25% more productive than without it. And if anything, I think over time, as my brain capacity has decreased, this number has increased. You know, I'm relying more on IDEs to help me out of poor thought. So from about 2004 to 2014, I was using very basic tools. So a text editor with syntax highlighting, which everyone has, Hoogle for searching, and Hugs GHCI for fast reloading. But the really interesting thing is, what was my cycle? How was my loop? Whenever I typed some code, what did I do? So it was quite a slow process. So I edited the code, I hit save, I switched to GHCI or Hugs. I was a Hugs user in 2014. I hit :R or kit up, then I hit enter. Then I looked at the error message. Sometimes that would scroll off the page, so sometimes I'd have to scroll back, find where exactly the error message was. Usually I only wanted the line and file name, and then jump to that place in my editor. So that's a fairly long cycle. And when you've got a fairly long cycle like that, it really discourages you from using the compiler as a fast feedback tool. It's more a check. It's not something you're using to interactively develop with. And in the course of an hour, I might have done this 200 times. And each time round the cycle maybe takes 5 seconds. So it really starts to add up. So this is why I think 25% is probably an underestimate. In 2014, I wrote GHC ID. And for those of you who haven't used GHC ID, just think of a GHCI process that someone else keeps sending :r at. And that's basically all it does. But that was a huge productivity boost. The cycle, now you avoid the switching window and then switching window back. You avoid hitting :r, and because of the way it formats the error, the file name and location is always at the top left, right at the start, and it does smart things with warning caching and stuff. But basically, the cycle has now had some of this bit in the middle chopped out. And that means I can go much faster as a developer, and I can rely on the tools to make refactorings. So instead of trying to guess what the compiler is going to say and react to it, I just get the compiler to tell me. So this was a huge boon, but now the time has come to move to a real IDE. Well, the time came to move to a real IDE about 20 years ago, but it wasn't ready. So now I'm using HighCore. I still use GHC ID as kind of a safety blanket, but most of the time I'm working an editor with HighCore. So for the first time, I'm using a real Haskell IDE. It's not best of breed. If you've used IntelliJ, or if you know people who've used IntelliJ, they will mock us when I show them HighCore. But for Haskellers, it's a step up. Everyone else, it's a step down. And now the cycle is reduced even further. I type code, and it goes red wiggly straight away. There's no save. There's no finding the error. It's just there. So now I can get an even tighter feedback loop. And also, because it's more of a full IDE, I've got full type checking on every keystroke, errors properly, more code navigation stuff. And again, I found that this is another huge productivity boost. So I don't like doing live demos, but I think it works well enough that I'm going to do a semi-unscripted demo of HighCore. So can everyone see this, or should I zoom up, make the... Control-Shift+, I'm told. Oh, this is a new laptop, so I'm still figuring out the keys. And I'll dunk this over here. So this is VSCode. This is VSCode, which quite a reasonable number of, all the non-Vim users seem to be kind of using. So this is loaded in HighCore, and so I'll explain a bit more later, but basically VSCode is, so VSCode came up with this amazing innovation about 2 years ago. So it used to be, you had a bunch of languages, Rust, Haskell, OCaml, C++, whatever, and you had a bunch of editors, Visual Studio Code, Atom, Emacs, whatever, and then you had a many-to-many relationship. So every language supported some editors, and it was a hugely expensive grid to fill in. So what VS Code came up with is the language server protocol. So this sits in the middle. It's an API, a kind of server protocol that says what a language must do to be supported by an editor. So the editors talk LSP, and all the languages talk LSP, and now you've reduced this many-to-many to many-to-one and one-to-many. So HighCore is an LSP server, so it sits, it talks LSP, VS Code talks LSP, and you can put the two together. So that's kind of where the boundary is. So VS Code is doing all the UI stuff, HighCore is doing all the all the stuff that makes this Haskell and not JavaScript. So the first thing I said I wanted is feedback when I type a syntax error. Okay, so let's type a syntax error. And immediately I have a red squiggly line. So GHC here is perhaps not being the best at telling me where the syntax error is, but that's GHC's fault. Here, we can do better. So you see, instantly, I type, I have error. I untype, I have an error. It's very nice. I can do the same with things like brackets. Very quickly, remove and add errors. So that's a very simple syntactic error. What if I add a name binding error? So here, it's now said return. I can view the problems output of VSCode, and it says, the error message you'd expect from GHC, variable not in scope return. Perhaps you meant return. Ah, indeed I did. And so I can put it back. And I could add a type error. So for example, if I type 1 here, now could not deduce num m unit arising from literal 1. Not necessarily the error that we'd be hoping for, but you can see I've got a very fast interactive cycle. So that's the kind of errors feature. For warnings, okay, well let's import one module we don't need, or import system. So here, I've got a warning. This import is redundant. Oh, I wonder if VS Code can fix that for me. Ooh. In practice, actually getting the error quickly is super useful. Fixing them automatically, it was easy to do, so I did it because it's cool, but it's more demo worthy than real. No. Yes, so LSP for any error, any diagnostic. So you send diagnostics, and you can send quick fixes with it, which is essentially, here is the diff to apply if you want to fix this diagnostic. So let's go on to some code navigation features. So atomic modifier ref. I always forget whether it turns A, B, or BA. And in this case, it's showing me the fully instantiated type at the particular type I'm using. So I've got the either coming in and the either coming out and the M unit. So I can see this code. I can also do it for things that are inside my, that I've defined within this project. So error internal is defined in this file at this location with this type. That's very convenient. If I press Control, it actually gives me the source code here. And I think I should probably report them to someone other than Neil Mitchell. So I'll go and change that. The other thing is, I'm not saving it, but this will propagate all the way through. Anything else here? No, probably that's about it. So I've got some reasonably good navigation features, some reasonably good go-to definition features, and fast errors. Okay, who thought that was something they might want to use? Okay, wow, that's a Haskell has always had this reputation of kind of not wanting an IDE, and I think it's just kind of Stockholm syndrome. We haven't had an IDE, so now we've decided we really don't want an IDE. So, unfortunately, setting this up isn't as easy as it could be. We've got a table down here where we've been setting it. I've been helping people set it up, but I'll kind of explain the fundamentals of how it works, which will help you figure out how to set it up. It also, at the moment, HighCore doesn't have enough users to be viable. So many Haskell IDs have come and gone, and none of them have managed to get critical mass that makes them a viable long-term project. But if everyone in this room was using it, we would. The other thing is, it's not really a big issue because no project has a viable mass of users at the beginning, and HighCore does have digital asset, a company with a bunch of employees backing it. Then after I've kind of convinced you, I've talked you through how to use it, I'll talk about how we built it. So building an IDE is actually quite hard if you don't know how to do it. And when I first did it, I did not know how to do it. Now I know how to do it. I want to share how easy it is with all of you. And then you can build an IDE easily too if you want. So if you want to install HighCore, come to this table afterwards and we'll talk you through it. But basically, go to this URL. You need to install HiBIOS from GitHub, unless Matthew? Cool. You can install HiBIOS from Hackage, so that makes it massively easier. So you can just install HighCore. It's at this location. You install a VSCode extension. There's also an Emacs extension, and I'm led to believe you can set up an LSP extension for Vim quite easily, but there is an instruction, so if someone wants to try that. But the hardest bit is making sure your particular project works with HighCore. And that, unfortunately, is a bit of a slog, and I'll kind of talk through that. So, that fun IDE basically relies on HighCore being able to load your code. So you can experiment with an IDE using the IDE, but it's much easier to use a command line tool to basically see, can my project be loaded in the abstract sense? And if it can be loaded in the abstract sense, outside an IDE, the IDE is probably going to work for you just fine. So if you install HighCore, there's a program HighCore, and when I run it in the shake repo, it spits out a bunch of stuff that it's thinking about. It found 156 files, 152 of them can be loaded in the IDE, and 4 can't. So for 152, I can get that experience that I showed you earlier, and those 2 files that I was editing earlier were in that 152. The 4 that failed, well, actually, they don't compile with any compiler. These are a model I was doing in the GHC 7.2 days, and they just no longer compile. So the hard bit is getting to this stage where you see all your project compiles. How do you do that? Well, so there's a project HiBIOS by Matthew that says how you load up a GHC environment for your project. And one way to do it, check the HiBIOS page for details, but one way to do it is just figure out the arguments I would pass to GHCI to start a GHC session. So if you look in the Shake project, in the root, I have this. So these are some warnings I like to have. So unused imports you see was on there, which is why I got unused imports. My code all lives in source. This is the root project. So this is kind of like where I'm curious about errors locating from. This is where the paths shake file lives. So you need to do the work to figure out how to load your project. And if you use HiBIOS, there are also ways to kind of integrate it with Cabal and Stack, and probably ways you could improve it in the Hi and Stack, in the Cabal and Stack cases. So the rough architecture of HighCore. So who's heard of GHC? Yeah. So we use GHC for doing all the heavy lifting, type checking, loading files, parsing. Basically, if your IDE ends up replicating that kind of stuff, it's going to go out of sync with GHC. So it's really important that you use GHC to be the kind of brains of anything Haskell related. I talked about LSP earlier. So there's a library called Haskell LSP that is basically the LSP protocol for Haskell. It knows about all the messages. It can serialize and deserialize them, JSON, and all that cool stuff. So this basically just is the protocol you need to talk. Then you've got these 2 projects. So GHC, very well established project. Haskell LSP pretty much implements the protocol, nice and simple. Then you've got these 2 projects, which are the projects that really have only existed in a workable form in the last year. Maybe have only existed at all in the last year. HiBIOS is about creating a GHC environment, getting you so that your code can be loaded in GHC, setting up paths, setting up extensions, setting up all that gunk that means you now have code in GHC. HighCore, on the other hand, is given a GHC environment that can build your code, orchestrate it. So build, figure out when to type check, when to pass, talk to the LSP server, do all the plumbing involved. If you take HiBIOS and HighCore and put them together, you get an IDE. And you get an IDE in about 20 lines of code. And HighCore includes an example IDE that is just 20 lines of code, which is the ones I've been showing you. Plus a few hundred lines for the HighCore debugging support. Stock GHC, yes. Yes, so at the moment, GHC 8.6, maybe 8.8 works. I don't know. I haven't tested it. 8.4 definitely doesn't work. It's too old. But I'm tempted to change that during this hackathon. No patches required, yes. So this is very important. So part of the philosophy for the HighCore work is you have to work with the vanilla GHC, and if the vanilla GHC, say, has patches upstream that you would really like, you have to copy and paste them into HighCore, and then get rid of them at a later date. Because otherwise, yeah, getting it set up is the hard bit, and you don't want to do anything to make it harder. So this was just what I went through on the last slide. I guess the only thing is you might hear the word cradles. That's HiBIOS's concept of how to configure with, say, Stack or Cabal or something. Yep. Yeah. So I said the IDE was 20 lines. So I guess saying the IDE is maybe a misnomer here. So this is the language server protocol that speaks to VSCode. I guess more what I was trying to say is you've got a bunch of stuff here in HiBIOS, you've got a bunch of stuff here in HighCore, which are totally separate and know nothing about each other, and then you just wire them together in 20 lines. Exactly. And VSCode will start that daemon, it will health check that daemon and everything. So there are other Haskell IDEs. There's GHC ID, which is kind of not really an IDE, but close. There's IntelliJ, which is a really good IDE if you like. IntelliJ has a Haskell mode. It's pretty well done if you like IntelliJ, which is not everyone. There's Leska, which has its own integrated editor, which at least for me makes it not an option because I quite like my editor. And I guess if you're Vim users, you probably do too. There's Intero, although honestly I've not heard much from the Intero camp in a while. I'm not sure what state that's in. And I guess the one that everyone has tried to kind of condense around is the Haskell IDE-engine, which is the most closely related to HighCore. So HiBIOS and Haskell LSP are, I would say, definitely part of Haskell IDE-engine. HighCore was named in the hope that it one day might become the core of the Haskell IDE-engine, but maybe it won't. And maybe it needs renaming. But, you know, there's some amorphous blob there. And Haskell IDE-engine is a lot more mature than this stuff, and it has Hugel and HLint integration. I've had issues getting it set up, and I think HighCore is a better design. And it's also got GPL3 things, but it is quite an effective IDE, so if you want to try off on that, you know, it probably needs more community love. And many, many other IDEs have come and gone, often as student projects. So, inside the IDE. So, writing this IDE was not easy. At one point, I was in charge of 6 things, one of which was the IDE, and I kind of thought, well, the IDE, that can't be too hard. It was the hardest thing we did. We went through 3 iterations of how to build an IDE, like the fundamental constructs, and threw them away because we got it completely wrong. And reflecting back, I think this is because in the Haskell world, we're kind of fortunate that essentially, if you want to solve a problem, there's an academic paper or a PhD thesis or a stack of them that describe how to solve it. Like you want to do optics, there are papers on how to write an optics library. You want to do a compiler, an optimizer, there are just papers on it. And yes, you have to innovate on top of that. But for an IDE, there's just papers on experience reports. There's not papers on how to actually build it. So think of this next 20 minutes as the paper, the talk that would go with the paper that hasn't been written. So the basic idea that we kind of coalesced on eventually was you need to set up dependencies for an IDE to work. So if you think about how an IDE proceeds, I've got a file. I then want to go to its contents, so the actual text that represents it. Then I want to parse that to build an abstract syntax tree. Then I want to see what it imports, so look at its import statements, chase down where those imports, and probably do the type checking, the parsing dance on that. And then finally, I need to type check it, but to type check it, I need not just this module, but all the modules it transitively imports. So it's very naturally a dependency structure. And the kind of simplification we came up with is that every time anything changes, you kind of evaluate this dependency structure. Every time anything changes, you just throw everything away with asynchronous exceptions, which is one of Haskell's great strengths, and start it all again. And if you have incremental caching, and you can skip the things that haven't changed, that's fast enough to do on every keystroke. And as soon as you get an error, you report it. So what does this kind of description remind you of? FRP would be one thing, yeah, certainly related to it. Certainly you could put this as an FRP system. What if you know my background, what would it remind you of? Build systems, Shake, and both of those are exactly the right answer. So yeah, you can kind of see an IDE as a build system, kind of. Yes in some ways, no in some ways. So it very definitely has dependencies, and dependencies are at its heart. That's great. It has incremental minimal recompilation, the idea that you skip things, if I type checked it and it hasn't changed, don't type check it. And it's got parallelism, which is certainly very nice side benefit. If your IDE can be multi-threaded, you can type check bigger things. But there are some ways it's not really like a build system. So the errors propagate weirdly and persist weirdly. What do I mean by that? So in a build system, usually you're compiling your program to get a working artifact at the end. So usually the good state is a working state, and that's what a build system is optimized for. Usually if you get an error, it'll just go, failed, this is why, fix it and try again, come back later. Whereas in an IDE, you're usually in an error state. So an error state has to become the normal thing. You also want to kind of report errors that you've kind of walked over but aren't going to hit again, like warnings. And if you hit an error later on, but something earlier in it kind of becomes erroneous, that error is no longer valid, so you need to clear those errors. So there's a really weird how errors propagate through this. The other kind of differences are sometimes you want stale data. So for example, when you do go to definition, maybe you don't have this file type checked in this iteration because you've added a comment. But if you have stale data, that's probably going to give you a better experience than just saying no. There's also the issue that you've got the errors. So with the LSP, you've got the errors kind of in the build system and in the VSCode IDE through the LSP. So there's a kind of shared state that they both need to agree on. It's also not quite incremental in the same way. So yeah, this whole throwing away all the work you're doing whenever you press a keystroke, that's not really what you want. Maybe something like FRP would be a much better fit there. And there's also the issue of garbage collection. So when I shut a file, I want that to disappear from memory. I want to release the resources associated with it. And that's not really something build systems which work on disk ever bother doing. So there's a mismatch, but there are a lot of commonalities. So what we decided to do, and this was after much internal debate, we decided to build it on top of Shake. So who's heard of Shake? Okay, that's pretty good. It's a Haskell build system, and basically what it excels at is expressing dependencies, and importantly, expressing dynamic dependencies. So you can depend on something, and based on that dependency, then discover what it subsequently depends upon, which is very important for something like when you're parsing to get the headers, to then be able to depend on the headers. And if you think about it at kind of the 1,000-foot view, it builds a key value map of this key maps to this value, but also using these other keys. And that's all it really does. By taking an existing build system off the shelf, we can take advantage of a lot of things like support for things like does file exist tracking. So there's a lovely GHC bug. If you have an include path that says this file is at location A or location B, and you put the file at location B, and then you add a file at location A, GHC will sometimes not notice the file has changed, and that while the file contents haven't changed, the file name to use has changed. So with Shake, we can do does file exist on the first one, then the second one, and get proper tracking of everything. But we had to add a few things to Shake, the core. So priorities, so we can say kind of prioritize type checking over static analysis. And Shake, before we got to it, always serialized its data to disk on every run. When you're running every keystroke, that's a bit painful, so we fixed that in Shake. So that's what we did to shake, but there were still quite a lot of things on my list of no's that weren't addressed by this point. So we wrote development.ide.core.shake, which is in the HighCore repo. And this is the wrapper that takes the shake API to the API we really wished we had. And this is where kind of, if Duncan wants to try implementing FRP in it, if you implement this API in top of FPRP, that could potentially be a better solution. Shake isn't perfect here. So what we did is we switched from storing values in the shake key value map to storing them in a parallel kind of shadow key value map. Why did we do that? Well, so one of the reasons is now we can get at the data whenever we want it without going through shake, so we can get at stale data. The other reason is we've now got the data in our hand, so we can throw it away and garbage collect it. And by garbage collect, I guess I'm not talking in the GC sense of GHC will know to garbage collect. I'm talking about throwing it out the map so that the GHC garbage collector can come around and clean it up. It also lets us deal with error propagation and error persistence because we've got the errors in a kind of controlled place on our own side. And shake, because it's very much a file system based thing, expects to be able to serialize every value you gave it, and that's not true of most of the GHC things like the TC monad. So we built this on top of shake, and essentially that means that the IDE is again a key value store. So what are the keys and what are the values? Those are the interesting questions for KeyValue Store. So a key in HighCore is always the key material and a file name. So for example, for type checking a file, the key is the pair of type check and the source file you're doing. So by kind of making the key structure a bit richer and always having the file name available, we can do things like reporting diagnostics in the right place. If type checking fails, we know it belongs to the foo.hs file. And we can do garbage collection. So when foo.hs gets shut, we can clean out everything associated with it very easily. The values was the thing we had a lot more struggle with. What is the result of an operation in this database? And turned out the right answer was a pair of a list of diagnostics and maybe a value. And I would say that this is the thing that between like the second and third version we figured out. So this took a whole version to figure out. So what do the various kind of structural inhabitants of this type mean? So if type checking works, I would expect kind of the empty list here and just the type checked result. If type checking returns warnings, I would expect some warnings in the diagnostic and just the type checked result. If type checking fails, I would expect an error here, a fatal error in the diagnostics, and nothing, because I wasn't able to produce the TypeCheck module. The interesting case is, what if one of the phases that type checking depends on fails? And there the answer is, this should be the empty list. There are no errors from type checking, but you should also have nothing here because there's no type checked result. And it's only valid to put that if you have a dependency that is given errors. So, if you say there are no errors and no result, that would be a bad thing if no one else is reporting errors for this file, because suddenly the user's got a failure and they don't know why. But that's the way you would propagate a dependency failed. And in practice, we use exceptions to imply this value, and then we propagate them up and catch them and turn them into this. So yeah, that's a key innovation. Who's used the GHC API? Who's happy? Okay, well, I'm glad there's one. So it is a scary place. IO-refs hide everywhere. If you look at a data type in the GHC API and ask, is there an IO-ref buried inside here? The default answer is probably yes. There are huge blobs of state. Like, the kind of global variables that people warn you about in imperative programming are in the GHC compiler, but they're threaded round in an IO-ref. Well, yay. There's the GHC monad that accesses this huge blob of state, and there's lots and lots of odd corners. And there's lots of stuff that isn't suitable for IDEs. So the GHC API is not a nice place for an IDE writer. And just to kind of give you an example of the kind of APIs that you might expect to find in the GHC API, I'm just going to rant a little about the warnings from the type checker. So how would you expect to get warnings from the type checker? Well, a reasonable thing would be a pair of the warnings and the TypeCheck module. That seems fine. But GHC doesn't do that. GHC makes you pass a function that can print out warnings, and then it will call that function that prints out warnings. And that is basically warning arrow IO. Okay, well that sucks. But we can do the clever trick of creating an IRF beforehand, making this print function put things in the IRF and then collect the IRF at the end. Okay, that's not so bad. Okay, and now we've got to put this printing function deep, deep, deep inside a structure. Okay, that sucks, but we'll live with it. And then, as a final insult to insult, it doesn't use the printing diagnostics function you give the type checker. It uses the printing diagnostics function you used the parser when you parse the module, perhaps days ago. It snaffles it away in an inner data structure of the parse module. And when it wants to print out a warning from the type checker, it goes and uses that rather than the one you just gave it in the field. So it's a bit of a nightmare to kind of plumb it up. And this is HSCM, which is one of the main types. You can see IORefs, MVARs. These things will mostly have IORefs and MVARs inside them. And then dimflags has 148 fields. It's a mess. So what we want for writing a nice IDE is a much purer API. And by pure, I don't mean not in I/O. I just mean kind of morally inputs to outputs. So a lot of the HighCore package is building things like this. So to TypeCheck a module, you want the environment, which is all the packages that you depend on. You want the module type-checked results of all the things you import in this package. You want the parse module, and you want to get out the errors and warnings, and maybe the type-check result if there were no errors. So we build those kind of APIs on top of the warning APIs we were given. And then, once you've built that, you can describe what type checking a module should be. And this is unadulterated code taken right from the IDE. And I'm very pleased with it. I think this is what convinces me we got the abstractions right. So we say at the first, the result of type checking is a TC module result. That's just what GHC gave us. And to define the type checking rule, you first get the parse module for the file. You get the dependencies for the file. You take the transitive module dependencies, type check those. You get the package state, and then you call our clean TypeCheck module, passing all that, and that returns you a TC module result and the warning. So I was very happy when we wrote this code. This to me looks beautiful. How closely tied is TypeCheck module to specific GHC version? Everything using the GHC API is pretty tied to a GHC version, but typically the changes between GHC versions are not significant in most areas. So like from 8.6 to 8.8, the syntax tree added trees that grow stuff, or maybe it was 8.4 to 8.6. So that broke everything that was using a abstract syntax tree thing. But the TypeCheck module interface, pretty much, maybe it got a few fields in the dim flag structure, but it's mostly the same thing. So you do have to do a reasonable amount of work to support multiple GHC versions, but it's not un-CPable. CPable. So, and the nice things about these, so this use underscore says if get parse module fails, so if you can't parse this file, just abort the whole thing. And that's why an exception is really nice here, because we just kind of jump straight out of the whole thing. This uses underscore says type check all the transitive dependencies in parallel. So you've got nice parallelism from the build system. And yeah, I just really like this code. So the other thing about IDEs is people often want extensibility points. I'm not sure if this is necessarily a good idea, but HighCore provides 2 of them anyway. So once you've got this dependency graph, you can put new values on the dependency graph. So you can say the result of, so liquid Haskell analysis depends on the type check results of this and this metadata and whatever. So it's very extensible in that way. And you can also define new LSP handlers. So LSP handlers are kind of features that VSCode exposes through the IDE. So this is some code, again, straight from HighCore. So there's a go-to-definition handler, a hover handler, and a quick fix handler, and you just plumb them together. So it's very easy to add new things to HighCore on the outside, although no one has actually done. So I talked about LSP handlers. These are the kind of that give you the LSP features. So this is kind of, rather than go into too much detail, I'll just give you kind of the broad overstrokes of how they work. So essentially, LSP gives you things like, I want to hover at this position, what should I show? So in the IDE, we turn that into, we give you the IDE state, we give you the position parameters, and you have to return maybe some hover information. And the typical way most of these work is figure out what they want to do, then call run action IDE, and then in here, you can call all the U's, get all the things off the dependency graph, and put them together in a way that answers the LSP question. So the internal architecture summary, not very interesting, but requests come in from the LSP and we compute them. So where do we go off-piste? Where do we not reuse things in GHC? And there's really one big place, and that's what GHC calls the DAU Swing. So GHC wants to get all of the files and do a big module dependency graph and see if there are cycles and all that stuff in one huge lump. That is completely unsuitable for the way our IDE is structured. We want to get the dependencies of one file. If there's a cyclic import or a missing import, we want to work with the bits that remain still work. And we want to do garbage collection on an existing graph. So we've had to go completely off-piste and write this code ourselves. This is not a good thing, because it means that things like template Haskell, CPP are harder. Things like HI boot files don't work yet. It's where we kind of incur the wrath of GHC changing in incompatible directions. So this is one place where it needs abstracting. What is the concrete abstraction underlying this? And sending upstream. But fortunately, this is really the only place we've gone off the wall, so not too bad. Was Shake a good idea? I think yes. It turns out that IDE is a very natural dependency problem, and what Shake really gave us was very well debugged parallelism and very well debugged exception handling. So if every time you press a keystroke, you send an asynchronous exception to your running graph in any arbitrary state, if there are any bugs with asynchronous exception handling anywhere in the code, it will die in seconds. And we've had several such bugs in the HighCore bit, but we didn't find any in Shake. Oh, yes, we did. So the GHC API, in particular, if you're in a template Haskell phase and you aborted at the wrong point, it messes up some internal data structures in the HSCM that it definitely shouldn't be. So yes, the GHC API mostly works, but the corners like template Haskell were balked. The other thing, which I kind of am learning now as a developer, is that actually having Shake meant we had a huge API and we could use whatever subset of it we wanted. So we could explore the problem space. Does it make sense to use this feature? Does it make sense to use this feature? Whereas if we'd written our own kind of dependency, we would have had to build we would have to do a lot more work to test hypotheses. So while we could maybe write what we have now without using Shake, we wouldn't have necessarily managed to follow the path there. But it isn't perfect. And the main problem is if you're running one computation and someone changes something, you don't really want to abort that computation. Sometimes if it's independent, you want to finish it. And what I think GHC really needs here is a suspend thread primitive. So in other languages, you cannot kill a thread without pretty much risking the wrath of everything, but you can suspend threads and resume threads. It would be really nice if GHC got that. So you could start type checking one module, use a precedent key, okay, suspend that. Is it still a valid, did I want to do the same thing again? Okay, resume. But we didn't bother. because if things are quick, it's not the end of the world, but it's not perfect. So I'm going to be hacking HighCore this weekend. And if you want to contribute to this effort, there are really 2 ways to go. Well, 3 ways to go. You can contribute to the high BIOS stuff, so make the setup easier. And to be honest, that's probably what stops most users getting started with it. And the ideal would be that all projects work out the box. And that is definitely not the case today. You can contribute to HighCore. So there are lots of things, new features, HLint, all this stuff. One word of warning, not really warning, but there is a contributor license agreement to contribute to HighCore, which some people dislike, but having spoken to some lawyers, I think probably all projects should get. And that's in the digital asset DAML repo, but you don't need to look at the whole DAML repo, just jump straight into compiler HighCore, and that's currently where HighCore lives. Maybe one day it needs moving up. So you heard the word DAML there. So DAML is a product from the digital asset company where I used to work but don't currently work. And it's a programming language that is close enough to Haskell that it can use the same HighCore as its innards. It's designed for DLT stuff, but isn't everything these days. Everything is open source, including the DLT bits that are so using the kind of the whole IDE that they build is open source, which includes HighCore as a part of it. And they're currently hiring in Zurich and New York. So if you want a job, email them, but not me. And there's an IDE for their full DAML. The other thing you can contribute is editor plugins. So there's Emacs and VSCode instructions, but not Vim instructions. So someone may want to do that, given all our Vim users in the audience. So these are the things that I'm planning to work on this weekend. Or these are the things that could be worked on this weekend, of which I'll be working on a few. So honestly, trying out, seeing if it works for you, and if it doesn't, filing a bug, figuring out or fixing it, and using it for real are the most important things for the HighCore project. There are some other things like HLint, Amulu integration, some adding tests, some things like multiple HSCM simultaneously, which I'm going to be talking to Matthew about. So there's lots of little projects to try, but if you just tried it out and used it, that would be the most useful thing for the project. And it would be wrong to finish without crediting lots of people. So this is by no means an exhaustive list. Matthew Pickering, sat over there, did all the high BIOS work. Alan Zimmerman has been running the Haskell IDE-engine project for some time, and it's really because of him and because of the changes he's been pushing into the GHC API project for many, many versions, that things like type checking from a buffer just work. And all these primitives are available, which is why something like HighCore really couldn't have been done 5 years ago, 4 years ago, because the preparations weren't there. And also maintains the Haskell IDE-engine, which is another somewhat related, maybe totally related IDE that you may want to try. And also the digital asset team, who've been the ones coding most of HighCore. In this photo, you'll see Gary, Moritz, David, and Shane, and Martin was off cycling that weekend. And there are some others at Digital Asset. Okay, thanks very much. Any questions? No.
One announcement, we have this nice throwable microphone. So in order to record all the questions,
Thank you, Neil. That was very nice. So my question is about the process architecture. Like, what are things in process? Where does the code live in various processes? And the reason I ask is because when Edsco and I were working on the ill-fated FP Complete IDE backend many years ago, before all of Alan Zimmerman's nice work, so Edsco bears the scars from that. We treated because as you said, GHC is a massive bundle of mutable state. We put it always in a separate process because there are certain things that you can't check, like static static flags, at least at the time, were things that you can't change. There's dynamic flags and static flags. And static flags, once you set them, that's it. Or like packages, once you load them for template Haskell or GHCI style things, you can't really get rid of them there. They're just, so the approach we took was to always put GHC in a separate process, and then just sometimes you say, kill it, and restart it, and try and recreate the same state. And I was wondering what approach now you take with where does code live in various processes?
So VSCode takes the approach that it does not want your crappy LSP server running in its process.
Of course, yeah.
So VSCode always spawns a separate process, and then it talks over JSON pipes with all the LSP stuff. So it's already in a separate process. And if that process dies, VSCode will restart it. So if you want to say the world has changed in a way that is incompatible, you would just essentially say goodbye to VSCode, and VSCode would bring up a new one of you. In practice, we haven't done that. We haven't found anywhere where regularly people fail to continue editing as they were. Maybe GHC's got better, maybe we just haven't found the corner cases. Maybe template Haskell, when we abort it improperly, we're going to have to do something more like that or mask it. Yeah, okay. But we've managed to get away with it so far.
Cool, all right. Next question, let's go.
First of all, I think it's really nice. I mean, we've been working on something similar years ago, and I think I feel your pain. It was working with the GHC API to do this kind of stuff is really a nightmare. I'm curious. You said right now. I'm just curious about, because you said you asked the question who wants an IDE, and often the problem is not so much that we don't want one, but with every new GHC version, with every new GHC mod, all these things, they break all the time, right? And so that's also why I've been asking you questions like, okay, how tightly are you coupled to a specific GHC version? Like, do you traverse the ASD? Like, how much pain is there? And so I'm curious, right now you say it's difficult to get your project started. Is that, what kind of limitations are there, and what kind of, what are the pain points?
So I would say we haven't yet got to the GHC. We've done GHC 8.6 and 8.8, but we haven't been around long enough to know if this will be a pain going forward. I mean, it will be a pain, but how much of a pain? I think if the community could settle on one answer rather than 100 answers, it would be a manageable pain, but at 100 answers, it's unmanageable. For the startup, the pain isn't the GHC API. The pain is that we've got Cabal v1, Cabal v2, Cabal global installs, Stack, Bazel, Buck, Obelisk, Nix. Just the people who came over, to find two people using the same setup was hard. And all of them have different include paths, different ways of finding the compiler. All the details are different. And one of the really nice things about the HighCore HiBios split is it's not our problem, it's Matthew's. And so Matthew's going to fix it for the community.
I see. So, but there's no specific features in my code base that might make or break whether it works with.
So, like HI boot files,
okay.
Template Haskell. If you're using template Haskell, you're fine. If you're defining template Haskell functions that you're calling in this code base, maybe, don't really know. It works for vanilla code bases. Quite how vanilla has to be is something that's still being figured out. And if we can fix the DAU Swing, we could make it just Haskell.
What's the biggest code base you've tried HighCore on?
So there is a many thousand line project, many thousand modules, I would say.
And it doesn't use loads of memory?
Oh, yeah. It uses an unpleasantly large amount of memory, and it's so because of the architecture. Typically, if you give it a few minutes to warm up, it's okay. But yeah, at that size, it's starting to be a problem.
How does that language server protocol server start? Do you have to start that manually, or does that get started by VS Code?
So you write a VS Code extension that starts it for you.
Okay. But I was just curious how it finds the project root, because I'm interested in using this over something where I have multiple Cabal packages and one Cabal project.
So multi-HSCM, that's something I need to talk to Matthew.
Right.
Essentially, it looks for a hi.yaml file which is meant to be a project root that covers everything you've got open in your editor. Hopefully with multi-HSCM, I've got some ideas how we could make it work for multiple projects. But GHC doesn't really understand loading projects that are all in memory and in different packages.
Yep.
So it's not going to work beautifully. You know, we're pushing into the limits of GHC there.
If it recursively walks up the tree to find a top level file, that's fine.
No. Well, so recursively walks up the tree to find the hi.yaml, yes.
Yeah. Cool, that's fine.
So, I have a question. In other ecosystems, particularly I'm talking about IntelliJ, for example, we don't have the dependency of the IDE to the compiler. So the IDE has their own type checker implemented, their own parser, and the advantage of this is that the IDE can do type checking and parsing and everything in their own style, and doesn't depend on the compiler pipeline. So for the Haskell IDE, are we maybe coupled too tightly to GHC?
So I mean, it's interesting. So there is the model that every IDE is taking, and the IntelliJ model. And the IntelliJ model is essentially re-implement your parser, type checker, and everything. So my view is, if you do that, you will just be chasing GHC. Like, describing the GHC type checker in IntelliJ form is not a task I would like to try. So I guess I think GHC is maybe too complicated and too unlike other languages to do that.
Too fast moving.
Yeah, too fast moving, as Ganesh said. Yeah, it fills me with horror, but
I mean, chasing GHC is something you do anyway. But on a different level, you're chasing the GHC API,
you do,
right?
But there are people who are full-time hacking the GHC type checker, but keeping the API mostly the same. So you have to do a lot more chasing. And I think Richard has a sabbatical at the moment where he's going to do a lot of GHC type checker hacking. I do not want to follow him.
As a follow-up question to that, so does this system support any kind of partial parsing of files? Like, if you make a little syntax error, like say I make a syntax error in module A, and module B depends on module A, can I still type check module B and continue, or does everything break down?
Everything breaks down. So it could use the stale type checked interface from module A, and maybe it should. If GHC had kind of a defer parse errors flag, that wouldn't be an unreasonable thing set in the IDE. So you could certainly defer type check errors. It doesn't at the moment, but that's a reasonable thing to add. Yep. I know people have tried this. In practice, I found that writing a syntactically valid Haskell file, especially when you've got undefined to replaces all the implementations, just not something I've ever kind of wanted, but I appreciate different people have different styles here.
So let's have one more question and lunch after that.
Right behind two pillars. So.
Okay, so I'll do a transitive.
So you mentioned this, you'd written this nice TypeCheck Module wrapper around the GHC API. I mean, that feels like it should just be in the GHC API. Do you think there's scope for moving some of this into GHC itself so that you reduce at least the risk of some of that chasing at the outer layer?
Yes, I think that would be a great idea. There are slight issues that when we say we're passing an HSCN, we're not just passing any HSCN. These bits of the HSCN are set up right, and these bits aren't. Like the home package table isn't set up right, but the or the home package table is set up right, but the transitive HI files in this package aren't. So it's a slightly, it's not as clean it's a very clean API for how we use it, but it's less clean for a general purpose. It's also only like 20 lines of code, because GHC kind of provides these APIs, they're just wonky. So this is more cleaning it up. But yeah, the idea is at some point to try and kind of produce these clean set of functions that everyone could use. But honestly, the down suite is the much bigger pain point for us, so that's where we've been focusing.
Thank you.
Okay, so thank you, Neil.
Thank you.